Hello everyone, I'm Xiaogan. Okay, now we'll talk about dynamic multicast. Dynamic multicast is also very simple. Just like dynamic uncast, you can perform some operations in Blueprint. However, it is more powerful and can be used in many places. Regarding the knowledge of dynamic uncast, this chapter is still quite basic, just so you know how to use it. In practice, you need to combine it with many other things to truly show its power. For example, our async action, which we will cover later. This is something I modified myself based on the engine, a very easy-to set of asynchronous mini frameworks. It's a relatively small framework. Anyway, it's a way of executing a set of code, an execution flow. It's still relatively easy to use. Okay, so let's first declare a dynamic unicast, dynamic multicast. Obviously, our declaration is quite special, so we definitely put dynamic at the very front. Dynamic. At this point, we need to add a mute. Then here, we give it a, you can see it no longer has a return value here. There is also a Spidey's delegate. Everyone can take a look. Actually, when we declare a delegate, there is also one called decker event. There are also some differences. It seems that event can only be used in its own location. I don't quite remember the specific differences. Let's mainly talk about this. Just use dynamic single wave. Okay, dynamic multi-wave. So now we declare a txt one with 3 parameters. Okay, we declare one with 3 parameters. We find it. We call it fx xiaogang, dynamic mutility, and 3. Then obviously, at this point, you need to specify 3 types. Then the first one is still called in name. The second one, now pay attention. Because this parameter name is not for you to, this part has meaning, this parameter name. When you match your function, this parameter name must be able to match. This way it often corresponds with the feeling. Then let's call this health. Health, then enter sensor. Then we call it in mana. It's relatively simple. It's just the player's status. Things like health and mana. Then next, do it like this. Actually, we can just follow the writing style of our dynamic single wave. For example, I declare 1 here, and then here. Then we can perform an operation here. For example, init void. Init. Dynamic. Yeah. We call it theta, just call it. And then when we pass it like this, we just put it here. Okay. And then we still use UFUNCTION. Then here we give it a blue cable and catagraph. We just give it an XG. Then you will find that this place reports an error. You also cannot use it normally, right? So this is very normal. It is very normal. You will find that it reports an error. Then just delete it. This is completely fine. But after you delete it, you will find that in the mixed state, it is fine. Actually, there is a slight operation here. That is, you can do it this way with our single pull. Multi-pull, the normal multi-dial is the same. You could say this is a slight operation. This is a slight operation. Make a note of it. Slight operation. Actually, the normal operation should be done like this. We give it a right, give it a suffix. Then we need to use up here. Here we need to use. That's it. Then what we need to do. Actually, it's done now. Then we just start it here. Okay, after starting it, let me demonstrate. This dynamic multi-dial is really powerful, truly powerful. It is actually a bit like a world distributor. But don't try to force the concepts of Blueprint and C++ together, because problems can easily arise. Especially when you are just starting to learn. You will find they don't match up. Here we find our delegate. Okay, this is it. We created subclass. Okay, then we put it here. Put it here. Okay, after putting it here, We put it here. We check its position, no problem. This scene is also fine. We can drag one into the scene. Then you can see that here. We are in begin play. We can bundle it like this. You can see here. Seems like found it placed. I'm waiting to input a bit more information. There's a problem with the placement. Hey, look at this. This is it. But it doesn't return a value, nor can it load or unload cargo. However, it can do some binding here. For such an event, we'll bind it. Lamb. We just need to input a lamb. Okay, similarly, we can also do a simple binding elsewhere. But if you have a binding, then you certainly have an NW, right? We might have missed some parts, but you must all keep this concept in mind. I emphasize again, this concept is a very important one. That is, if you bind it, 特区主卧 hi the instead of not doing so, you can directly bind all the delegates here, like this. You can make it unbind specific ones. Sometimes we might miss it, but this is very important. So I have emphasized it again for you here. Then you should write it like this. This way is fine. Then we can further supplement and improve it in the level blueprint. Okay, we find its reference. We can also go here, bound event 2, right? Bind an event. And then this event, we custom event. We can give it a name. We won't use this name either. This is not important. Then we give it a health. And after we execute it, we have him unbind this event. It means we only execute it once. You might not understand. Why is this part written like this? But you need to know now. After you finish this business logic, you should know to search for this tail. Search for this tail. Then here we still use Arigevio. And then note here we get it. Then we broadcast. Take a look. XG dynamic. Let's take a look at how this should be executed. This is the same as assigning an event. It seems like there's no way to see how it's executed here. Then we might need to expose a method for it to execute. But these operations, you can completely do these operations in C++. There is absolutely no problem with that. Just like before, we write an actor, then through the actor, obtain our multi-wave delegate actor, pointer to this object, then call it through the pointer. Then we guide it here. It needs to be different here, because I will from this place declare one yourself, such an actor object, then get it. It's actually the same. Okay, we should give it here. Add an execution method. Then we void. Then we give it root. Dynamics, right? We might need to pass some parameters here. We can take this function, copy it over. Okay, pay attention. Actually, this place here is for execution. It is not the place for receiving bindings. It is for execution. It is not a binding. Pay attention to this part. If you write it at the beginning, you might feel a bit confused. That is perfectly normal. To avoid confusing you, I call it a call. Like this, okay? So here, our operation is actually like this. Broadcasting it this way, 这是 broadcast. We pass these three data in. Yeah. Okay, so after doing this, let's still write a C++ binding for everyone. Well, obviously, this is called work dynamic. We call it light. So our delegate will bind three methods, and we don't need to. We use we just let it print. And the function signatures here must be consistent. As for the log here, keep it simple. Dig a temp, and here we need to use this. 湖盘的20ตัว3 vtxt. We give it a 214 HEA dynamic to T5. Okay, now we need to bind it. We'll just bind it in begin play. Bind it here. Okay. We can call and add here. This is done by passing a. We can do it like this, AddDynamic. Actually, it's written like this here. Okay, let's take a look. Function and function name. We give it this. Then for the name, we'll attach a function to it. Attach one to it, avoid not finding it. This is actually very similar to how we write collisions. At this point, we give it a name. Of course, this is definitely not a U function. This. Okay, let's take a look at this. We can search for it. Search and see how the engine writes it. Oh, the engine still uses this style. Then let's just use the engine style. This is dynamic style addition. In fact, in C++, this is how it is done. You can see. We can see that it is missing the address of operator here, right? Then we can take a look at the engine. It is used in many places. You see, the handshake is also bound to this world as seen here, right? Okay, so we have already bound it like this. Then let's go to our level blueprint to call this dynamic multicast. Its calling method. Okay, then actually here we are. In our level blueprint, it should have a hook to execute our multicast. And note that for a name we give it. We actually don't care about these things. We give it a 99. 66. We mainly just look at our log. Note that this one only executes once. This black key only hits once. So the first time we should hit 3 objects. And when we execute the second and third times later, there are only 2 objects. You can see we hit 3 logs. Look at the NPC. And then our work come to T5. Dynamical T5 and 99. But the second time, there are only 2. So there is an unbinding operation here. A can only has 2. And the first time there are actually 3 of them. Because we bound this in the level blueprint. After we finish executing, we essentially unbind it. Okay, as for dynamic multi-wave, that's about it. One more thing. Actually, if you want to remove it, you can just remove it through this. Remove it through this place. See, pass in this object, pass in this method. This is the removal. In the addition, perform an addition and removal. Then pay attention to one special point. The special point is right here. You don't have it directly. You will find it is done in this way because it is a dynamic multicast. So it has an interval in front of it, something like that. If you want to call it, you can just call it like this. There is no problem. That's all it takes. Oh, that's all for dynamic multicast. Thank you, everyone.